Have we talked about bias?
Yes.
We did? Okay, well, now we're talking about graphical misrepresentations. Remember I told you that there are two types of errors in statistics. All right? There are two types of errors. What are those two errors? One starts with a B, bias. What's the other one? Starts with I, ignorance. No, I'm just kidding. Making a mistake, making a mathematical mistake, making a graphical representation mistake. Let's say that, and I've probably used this before with you, let's say that you are a mathematician or a statistician, and you are working blah, 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 blah. You can be a division chair, department head, whatever. You're working blah, 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 and you want to make a folder. You want to make a portfolio of what you're doing. So you send your information down to graphics, and they put together the portfolio, and they take one of your graphs, and the person that's doing the graphics has got a 2-year degree, which is nothing wrong with a 2-year degree, but they don't have the mathematics, okay? And they just make up a picture, and they misrepresent your data. Well, that goes under the line of not bias. Just say bias and not bias. That goes under not bias. It means a mathematical or a judgmental or a educational error, okay? Whatever you want to call it. So there's two types of errors in statistics. Now, most of these you could say are non-biased, but sometimes they can be biased, all right? That's when you see a picture and it doesn't make sense, all right? And it's usually in the pictographs or the graphs. All right, that's one. That's number one. I'm keeping count. All right, usually you can tell with the pictographs, but I'll show you a good example. I'm looking for the soccer ball, wherever the soccer ball is. I hope they didn't take it out. Soccer ball is a good example. There it is. All right, I want everybody to draw a picture of the soccer ball best you can, okay? Because that's what I would put on a test, and you need to see it for the standardized test also, those of you who's going to have it. Now, I want you to, it really doesn't matter. They're showing growth in soccer participation or soccer fans, whatever, okay? And it says blah, 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 blah. It tells up top. Soccer continued to grow in popularity as a sport in the United States, okay? Players, Hope Solo, I've never heard of them, have helped generate renewed interest in the sport at various age levels. In 1991, there was approximately 10 million. By 2009, this number had climbed to 14 million. Okay, write that down. Write that sentence down. And somebody tell me what's wrong with that. What's wrong with the pictograph? And I'm looking for I want you to certain reasoning in your answer. Don't just say, well, it's wrong. No, that's not what I want. I want you to look at the graph and tell me why it's wrong. You know it's wrong, but why? Yes, sir.
Because it's showing more growth than just...
Okay, tell me how you come up with that.
Because in 2009, the soccer participation ball is like exponentially bigger than 1990.
How did you come up with that, though?
Usually, like I looked at it.
Just looked at it, but tell me what you're looking at.
The different sizes of the balls.
Exactly. Look at the size of the 1991 ball. Okay? It pretty much is the same size as the black part of the soccer ball right there, right? So let's look at this. Let's use a little bit of mathematics. All right. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe with these two. There is 10 little balls represented right there. You see what I'm saying? So that picture is showing that the participation, blah, 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 is 10 times more in 2009 than in 1991. Okay? Now, what would designate this as bias? Well, let's say that the person who did the stats is a soccer player. Okay? Now that would be biased because the soccer player took this graphic and made it out to be, or the soccer player statistician did the numbers right, but the graphics person what? Did the graphics wrong. Okay, there's two explanations for this. One biased, one not biased. But there's no way you can mathematically support an increase of 4 what, million? With a ball that's 10 times bigger than the original. See what I'm saying? That's the error. And you'd be surprised on how many people will look at that and they won't think anything of it. Do you see this a lot in publications? Yes. Now, whether it's biased or not, I don't know. It depends on how the graphic actually got into the publication, all right, which newspaper or magazine. It depends on how it got there and the research that was involved to see, you know, and you have to think about that. And that's the difference between a redneck and somebody that's educated, all right? The redneck's going to look at it and say, golly, that's 10 times, golly, you know, and they're not even going to pick up that it's a misrepresentation, okay? So that's a good one. There's another one with an OIL barrel. So let's see if we can find it. It might be in the homework or whatever. And you'll see a couple of these on the test, okay? Because these are good standardized test questions. They're quick and to the point, and a lot of standardized tests use it. What will you do with any kind of circle graph? You will always check it to see if it adds up to what? 100. Just like my test question I give you. 30, 30, 30 against 20, 10, and 70. 30, 30, 30 doesn't equal what? Doesn't equal 100, so it's not right. Okay, when you're dealing with a pie graph, always check to see if it equals 100. That's one of the things they give you on that one. Look at this one. 20 and 10 is 30. 50. 60. 70. That looks like it's over. Well, go ahead and add it up and see. Add it up right quick. I drink my cranberry and vodka. Got to start early. Huh? $47. It's 1 over, isn't it? I thought it was. Okay, so that would be a no. But you'd be surprised on how many people look at it and say, "Good God Almighty." You know, they'd say they make a distinction on it, but the first thing you need to do is check to make sure it's valid. These are good standardized test questions. Where's my barrels? You should have a barrel in here. There it is. There's the OIL barrels. All right? I don't pronounce OIL because there's always some smart aleck that pronounces it with a nasal Pennsylvania accent, so I don't pronounce it. OIL. All right, so what's the difference there? Well, you've got a difference of what? Somebody takes 691 minus 7 or minus 8. Okay, that's a lot, right? That's a lot. This what, 600 or 700, 680 something? All right. The whole point is, how many barrels can you fit inside that big barrel? How many of those barrels can you fit inside that barrel? 4, maybe? Well, they're only showing a 4-time representation when it's supposed to be. That barrel 7.5 needs to be about a quarter of the size it is right now. It needs to be way smaller. That's a good question on the test. Okay? What's wrong with that cost of raising kids? Doesn't equal 100. What does it equal? Let's see, 33 and 20, that's 53. That'd be 51. Dang old 66. Dang old 77. Now see, this is where you see a lot of bias. You see a lot of bias sometimes in political polls. I said political, okay? Political can mean a lot of things, okay? I don't want you going to my department head saying I'm talking about politics. I'm talking about a political poll. I didn't say any side. I didn't say any, okay? Anyway, political poll, they'll just leave off 30% that didn't say whether, they'll just leave it off, okay? Whether it's one side or the other. They'll just leave it off and say 55% said this and 45 or 40% said this, but the rest of the 10 or 15%, They won't even say what they said. Okay? And they'll just leave it because they're trying to get a point across. And sometimes you can do that. Sometimes you can do that if 5% said, oh no, well, you can leave them off because they got their head stuck in the sand anyway. I'm talking about when you're talking about current events and stuff like that. If they got their head stuck in the sand, but if they have another opinion, it needs to be, out there. But, if it's less than 5%, then I can understand why you wouldn't. But you can incorporate another opinion, it's a 1% and 5%, and you can say other / I don't know. You could say that. You always want to keep your numbers to 100. You don't want to leave out anything because some people may take that as being misrepresentative or being biased. Okay? Or some people might think you don't know what you're doing. Okay? So those are 3 good examples. So if you want to write 3 good examples down, there's probably another one. Let's see, 36, 47, 55, good God, 66, 75, 70, be 83, 82, I don't know. So add them up and see if they equal to 100. They're right at 100, close to it. Is that 100 even? Okay, so that one would be correct. So you got 4 examples there, and that's what I would put out. If I was to put anything from this section, it would be those 4 examples like that. Real simple, and, you either check to see if they equal 100, or you check to see if they're rationally proportional to each other. Okay? So the 2 pie graphs, 100, and then the 2 graphic representation, the OIL barrels and what was the other one? Soccer balls. That's your 2 examples of each. Capiche? Okay, now let's move to the math. And to go to the math, I use an Excel spreadsheet. Okay? I use an Excel spreadsheet because I want everybody in here to master Excel spreadsheets, right? No. I use it because it's the only way I can get everything on a dadgum piece of paper. On this dadgum board up here. Because when I start writing math, I'm one of those teachers that have to have like a big old blackboard that slides up all the way across. I can't write, very small. So that's why I do this. If you know how to use Excel, that's great. More power to you. Okay? But if you don't know how to use Excel, then you use your calculator. I don't use a calculator because it takes longer to do it with the homework, and I'll show you than it does the Excel spreadsheet because you can actually hit the button, send it to the Excel spreadsheet, and you don't have to type in all those numbers. Okay? Especially with those that have 25 or 30 numbers in it. So I use the Excel spreadsheet. We'll start off, and this is all of Chapter 3, except for z-scores and frequency distribution, which I'm going to hit again. I'll probably go over all of this first. This is regular data-driven statistics that I'm going to go over first. Then I'm going to go over frequency distribution, mean and standard deviation, and then I'm going to go over z-scores. Okay, so that's Chapter 3. All right, you can look in the book if you want to, but that's what I'm going to go over the next 2 or 3 days. Okay, so and then we'll go over homework questions and all that stuff because I'm going to hit all the homework questions at once since we're doing a lot of reading, a lot of definitions and all that. I'm going to go over the homework all at once. So anyway, what do you do if you have data-driven statistics? Well, first of all, you find out what N is. N is equal to a certain number, like 8 test scores. Let's start with 8. Okay? And let's say that your test scores are 72, 75, 80, 80, 81, 85. Let's see, how many is that? 6, 85, 90, and 98. That should be 8. All right, now I want everybody in here to find the mean, median, mode, range, mid-range, variance, and standard deviation. Whatever you can't find, leave it blank. Okay? Because we're going to go through all of those, and I'm going to go through how to do all of them, and then we'll do 3 or 4 examples, and then we'll pretty much be done with the data-driven. This is data-driven, meaning test scores. The opposite of data-driven is frequency distribution. And we'll go over that next. So go ahead and I'll make it a little bit bigger for you because I know somebody, I can't see. So we'll make it a little bit bigger. There we go. Now that's not big enough. You need to move. All right. There we go. So take a minute and do as much as you can. Mean, median, mode, range, mid-range, variance, and standard deviation. Whatever you can't find, just sit there and be a failure. Or disappointment, whichever one you want to use. So besides The Nun, anybody go see a movie this weekend? Any good movies?
Was The Nun good?
It was good.
Or The Spirit?
Yeah, I said it was a 7. Yeah. I'll see Predator Friday, probably. Did you tell your dad he was a disappointment, Miss Kathy? Okay, make sure you tell him that. I got to take up for Daniel. He's got 2 sisters. It's pretty hard on him, so he's outnumbered. God, he's just like his daddy, though. And he is. He's just like him. He got that laid back attitude. Oh, well, hurricane's coming. I guess we'll just take it in stride. Meanwhile, all of South Carolina's going bonkers. Now, South Carolina's one of those states, just weird. Just weird. One snowflake hits the ground and, oh my God! Hurricane's coming and everybody's going to run at it like a bat to a flame or whatever. I'm going to fight this hurricane. One snowflake falls. Oh my God! We got to cancel everything. It's supposed to hit like Wednesday or Thursday, but it's going to hit only Greenville. WYFF has done scared everybody to death. It's going to jump over every other county in South Carolina. It's just going to hit Greenville. WYFF is a joke. I'm sorry. It's a joke. Try to scare people to death. That's what you do when you're with local news.
Oh yeah, I love it too.
If we have this, get a lot of range.
Mom said as of right now it's just Katie and Greg, but it's gonna be Greg's whole family.
For those of y'all that don't know, we're in the upstate. It's like the mountains, okay? We might get rain, okay? And we might get a lot spin-off tornado. But we're not going to get nothing like Charleston, Fayetteville. We're not going to get anything like that. Even though WYFF says you need to go get your survival kits.
Oh yeah, I have to take a shower at Angeli's.
Get your survival kits at Bilo. And people wonder why they don't take it seriously.
Last year my mom got free vacation.
Oh, and go get bread and milk. Get bread and milk. Don't get beer and pizza. Get bread and milk. So you can make bread cereal. I have been living in South Carolina for over 50 years, and you have to get bread and milk. You have to get bread and milk. And one snowflake falls, you go to buy low. They ain't got no bread. They ain't got no milk, no bread. All the rednecks go out and buy all the bread and milk for some reason.
All the water. That's what Kelly went and you guys stand to buy all the water.
Okay, so I guess y'all are done, right? All right, so let's go over this stuff. And again, this is kind of stuff that you've been doing since you were like in 7th grade, okay? All right, what is the mean? The mean is also called the average. It's also called X bar. It's also called what? Mu. All of those equal what? Equals the summation. Wait a minute. The summation of these guys divided by what? N. So divided by that, and y'all should come up with an error. There we go. Always come up with an error. Divided by, there we go. Everybody should have got that. And y'all feel good about yourself. Median. When I say the word median, what's the first thing that comes in your brain? The middle of the road, right? Dang old concrete median or the yellow median. Some of y'all that use it as a turning lane, get out of traffic so you won't stop up traffic. Oh no, we stay in the left lane and turn and take 20 minutes. No, forget it. Anyway, the median is the middle. Now, when I want you to put out beside median, I want you to put observed. Okay? It's not the mathematical middle. It is the observed middle. What is the observed middle? You've got to put all your data in what? In order, right? And then you find the middle by observing it. You look at it, okay? You're not finding the middle. That's called the mid-range. Calculated middle is the mid-range. All right? That's what you calculate. All right? So anyway, this is the observed. So you take, now write this down. Since n is even, you find the average of the middle two numbers. Write that down. Since n is even, you find the average of the middle two numbers. Okay, she's back. Quit talking about her. She's a Gamecock fan. Leave her alone. All right, so I'm going to take my handy-dandy highlighter, and I'm going to highlight those two numbers. And I'm going to come over here and highlight this. And then I'm going to say equals, parentheses, this number plus this number. Now, I've got several degrees, okay? I know what the average is between 80 and 81. All right, but those numbers are not always going to be very straightforward. I'm just doing this to show you how to find it, okay? I have some people that think they know the answer and they think they created Space Shuttle. Divided by 2. There we go. Mode. What's the first two letters of mode? M-O. What's the first two letters of most? M-O. So it's easy to remember. One that shows up what? The most. Can you have more than one mode? Yes. Dang old monomodal, bimodal, trimodal, and polymodal. Does the mode mean anything? Not really. It doesn't mean anything. Okay? Statistically, it doesn't. It just shows you how many numbers show up, which influences where the middle is. That's the most important thing about statistics is the middle. And that's the mean, the median, and the mid-range. Those three numbers tell you a lot. It tells you if you got valid data. If your data is valid, those three numbers are going to be very close together. If your data is all over the place, then those numbers are going to be far apart. Okay? The far apart your numbers are, the farther your standard deviation is going to be. The closer your numbers are, the more tight your standard deviation will be. Okay? You'll see that in just a minute because I'm going to show you. That's my job. All right, so most. Which number shows up the most? 80. Now I'm going to put that in red or some kind of red color. I really don't want to put it in red because I don't like red. So we're going to go with dang old mauve. How about that? Okay? I know my colors. Dang old feminine side. All right. Mean, median, mode, range. What is the range? So why do you get it? The highest minus the what? Okay, if you get that wrong on a test, you don't what? You don't tell anybody. Mid-range. Mid-range is a very important part. Mid-range is kind of like the midpoint. It's the calculated middle. Okay? The calculated middle. So you do that by using the highest minus the lowest. You use the highest plus the lowest, and that's going to give you the mid-range. And divide it by 2. So equals parentheses, the highest plus the lowest divided by 2. Now you should be writing all this out to the side. The highest plus lowest divided by 2. Now, as you can see, the mean, I'm gonna highlight this one green, dang over day, and the median per day, and the mid-range per day. Now you see that the data is not too bad. You got an 83, an 81, and an 85. So the numbers are pretty much what? Clumped together. Those three that are in per day, dang old green, those numbers, if they are close together, then you're talking about good data, meaning that you don't have a lot of outliers. Okay, we'll go over outliers in just a minute. Capiche? Okay, now, let's talk about these numbers right here. What are these numbers called? Well, they're test scores, yeah, but what are they called as far as the variable? That's 2. What are these numbers called? We used n, so it can't be n. What's the most popular letter used in mathematics? X. These are our x's. Okay, now I'm going to put, that's a little lower, that's an uppercase. There we go. All right, now I'm going to put the formula for variance on the board. Okay, and I'm putting it on the board for a reason. I want you to read it as we use it. Okay. Let me just get this out of the way. Why doesn't this thing, I have to use the mouse first. I don't understand that. I do, this is motionless. No, this didn't work. There we go. This is a miracle. The Russians came in here and took it out while I was now it's not working. And it's not working over there either. There's something still wrong in this room. Well, I'm recording, so I'm going to have to write it up here. More than one way to skin a cat. I love cats, so don't take that literally. Okay, so the mean is equal to, or the variance, I'm going to put a V here, is equal to the summation of x minus x bar raised to the second power, sorry, it's hard to do with a mouse, divided by, if anybody wants to come up here and do it for me, you're welcome to, n minus 1. All right, write down variance, because I wasn't going to try to write variance down there. And now I've got, now see, there's something going on quirky, because that line, that squiggly line, is not showing up on my, so let me do this. Oh, and it won't erase either. So that tells you right now something's not right. It's a conspiracy. See, I can't even click on it. So I can click on this. Something quirky going on here. Anyway. Okay, so what do I need to do this formula right here? What's the first thing I need to do? I need to subtract x bar from each of my x's, don't I? So I need to call this column right here x minus x bar. X minus x bar. I'm just going to type it in. Let me just do that. So I want each of you to take x and subtract x bar from each one. Okay? X minus X bar. Now what is X bar? $82 point blah, blah, blah. And I'm going to hit F4. Now for those people that know what Excel is, what does F4 do? Anybody know? It locks it. Okay? If I'm to copy this down, what does Excel do when you copy down? It takes the next one and subtracts what? The next one over here, 80.5. Then it'll take the 80 right here, and subtract what? 80. And then it'll take the 80 right here and subtract what? 26. So you got to lock what you're trying to do. So I'm locking the 82.6. See it have that dashed line around it? I'm locking it so it'll take 72 minus 82, 75 minus 82. So that's what the F4 does. Foxtrot, Fox 4. So if you want to lock it, it'd be F4.
Should we include all 0.65?
Yes, check it all the way. When in statistics, you round off when? At the very end, your answer. So you don't round. If you take it to 4 or 5 digits, that's a good thing. All right? So now I'm going to copy down. So you grab that little right hand. Let me ask y'all this. Y'all are high school students, right? Most of y'all? How much exposure do y'all get to Excel? You are kidding me.
We took a computer class, and I think we probably.
I only use it for my bank.
Do you know what the number one, besides word processing, you use in the real world? Oh yeah, that's right. They don't teach you real world. Okay, yeah, that's right. They're doing what they're supposed to. Yeah, they don't teach you about accounting. They don't teach you about taxes. They don't teach you about Excel. Yeah, they're doing. That's right.
They do in 9th grade.
Geography for no reason.
Yeah, well, you know, geography. You're going to need that when you're on Jeopardy.
I know because
Of course, we
nobody.
need to know.
Yeah, exactly. Yeah, you need all that. I'm not saying that some of you, but one of the things that I think you should have a test on before you graduate: civics and real world finance. Those two things, I think everybody. But think about it. If you're ignorant in civics and you're ignorant in finance, then it's easier for you to be controlled. Think about it. I'm not a conspiracy theorist, but I do believe that sometimes government can get too big. And I think the best way for government to get too big is to keep people what? I'm sorry, what? Keep people, let's say, covered. How about covered? No, I don't like to use the word ignorant, but think about it. How much time do you spend in high school on civics and real world finance? And I'm talking income taxes, how you pay your income taxes, how it comes up with your income taxes, how you do your bank accounts, how you balance your bank accounts, and civics. And that's everything to do with government. Yeah. I'm sorry, what? Did you? I'm surprised they offer that. I really am.
Well, I have a class on it too, so they have the program, so you can't.
Yeah. I teach a 103 class here. I would suggest you take it if you want to take another class, in the future. But we do a whole section of income tax. And people in my class are usually grown, out of high school, non-traditional students, and they are overwhelmed by what they do not know about their own income. And it's real basic. Real basic. There's introduction to income tax. And they have no idea what's been going on. And they go, you mean I pay 25% of every dollar to, yeah, you do. And if you make it, and heaven forbid you make a lot of money, what's your last name? Mr. Cox decides he wants to make a widget. And he makes a widget, and it takes off across the country. And he makes millions and millions of dollars. How much of his money goes to the government? How much? 40%. 40%. Do you know that? Oh, I didn't know that.
That was ridiculous.
Yeah, but if you don't know it, you won't care. And that's why people, come out of high school, they don't know this stuff, and that's why they go to a school they can't afford. They get these student loans, they get underwater firefighting, and they make bad decisions because they are brought up to make what? And if you have parents that are not, and I don't mean this in a bad way, if you don't have parents that are educated in, the academia and how they manipulate people, you can get in a trap real quick in a degree that you don't need and classes that you don't need. So make sure because my mother and father, my father was educated, but he didn't. He said, "You can take that," even though I didn't know the math. You can take it. He was one of those type fathers. My mother, she just grabbed me by the ear and pulled me up Tri-County Tech. You're gonna go to school. That's what my mother was. But anyway, they trusted a lot of the counselors and a lot of the advisors, and 60% of the time, the advisors and counselors are good. Okay? There's a difference. I know, I'm being nice. There's a difference. Okay? And let me tell you this also, and I tell this to all my advisees. There's a difference between explaining concepts and trying to get you to believe in concepts. Always remember that. There's a difference. If somebody is telling you that you should not do this and should not do this, you're being indoctrinated. You're not being taught. Me teaching you bias, me teaching you how to do this, me saying that you need to do this, you need to do this, I'm teaching. But when I start to say you should, and I start to say you shouldn't, when I say those words, it's different. You see what I'm saying? You do the research, you do the knowledge, you get the knowledge about whatever subject you're talking about, whether it's with math and science, there's not much alternative. You're either got the answer or what. But a lot of your humanities, especially in economics, don't let somebody tell you, I sat in an economics class and I won't sit in it again. Because the teacher was basically indoctrinating the students, telling them that they should believe in this versus believing in this. And that's not teaching, that's indoctrinating. And you shouldn't indoctrinate students. You should let the students teach themselves about what they believe in. I'm very against that. I'm against that with a lot of things. That's when you start infringing on people's freedom. I don't like that. You ain't gonna find too many veterans that like it. And you start messing with somebody's freedom, that's not right. Okay, I'll shut up. I'll get off my soapbox. All right, so x minus x bar, and then what are we going to do with x minus x bar after we do it? What does that exponent mean? We're going to square it. Square. For some of y'all, it means square. We're going to square it. So x minus x bar, quantity squared. And I'm going to take this guy, and I'm going to raise him to the second power. Check your numbers. And then what am I going to do with x minus x bar after I square it? What does that funky E mean? Summation. Yes, summation is a 25-cent word for add them all up. So I'm going to go down here and look up there. Look up here. What's that? Auto sum. I'm going to highlight those answers and hit enter. And that is our numerator for our variance. So you go over here, and for some reason I can't draw. So I go over here and I'm going to say V is equal to 4. I'm just going to say 484 because I don't feel like writing all that out. 484 divided by, now I'm a good teacher, I'm going to help you out. I'm going to do the bottom for you, B7. There we go. So somebody crank that out. I'm going to crank it out legitimately and do the decimals up here. So I'm going to put variance right here equals and that's going to be equal to this guy divided by 7. I get that. Now, does the variance tell you anything? No. Okay? So why do you get it? Well, now you can find the standard deviation. Write this down. The standard deviation is always the square root of the variance. So write SD is equal to radical variance, VAR. Put the variance under the radical. And highlight that.
And then variance squared.
The
Standard deviation squared is.
the opposite. You take the standard deviation and square it, and you get the what? The variance, which you really don't ever do. That may be taught to you in high school because you never do it in real life. Okay? Take the square root of the variance, and you get the what? Standard deviation. So go ahead and take the square root of that number. It's going to be around 13. I'm sorry, not 13. I'm thinking 169. Shut up, Hubert. Standard deviation. Now, get used to this, especially if you're going into calculus later. All right? Take that number. You don't take the square root of it. You raise it to the what? 0.5 power, or 1/2 power. In calculus, you don't use the radical. You put everything to an exponent. So that's x to the 1/2 power, or x to the 0.5 power. And that comes out to be what? 8.3. Now, what the heck does that mean? Well, y'all pretty much know what the median, the mid-range, and the mean mean. Okay? The range is really not important. It is later for your box plot. Right over here for the range, put over here a box plot in parentheses because we're going to use that for the box plot. Okay? That comes in handy with the box plot. The variance and the mode, they're pretty much, I don't care. The only reason you know how you need to get it is because the homework and the test questions may ask you. Okay, I really don't care about it. I care about two things, the mean and the standard deviation. Because when you draw, I have to do it over here. When you draw your handy dandy bell curve, this is so aggravating to do with the mouse. Draw that bell curve and draw 3 lines on each side. Draw it hopefully a whole lot better than that. But like I say, anybody that can draw the mouse, come on up here and do it for me. I appreciate it. Very aggravating. What goes in the middle, do you think? What goes right here? The mean. Write down the mean. The mean, and we're going to round it because I don't want to worry. This is for your instructional purposes only. I don't want to have to worry about the decimals, so we're doing this, okay, 83. All right, so my mean is 83. You would do the decimals in real world and homework and test questions. All right, and then I'm going to add 8 because 8.3 is my what? Standard deviation. I'm going to add 3 times to the right, and what am I going to do to the left? Am I going to add or subtract? I'm going to subtract. And that's going to give us our window, and I'll show you what that gives us. So 83 plus 8 is what? 91? 91 plus 8 is what? 99. 99 plus 8 is 107. Now I suck at subtraction. So 75. 75 minus 8 is 60 what? 7? Somebody check me. 60 what? 60 what? I thought so. I thought I heard 73. Okay. And 67 minus 8 is 59. That 59 goes with that last mark. Okay. Now, that's what you do with your normal curve every time you get the mean and the standard deviation. Okay? Now, I'm going to have to draw with a highlight. Between 2 standard deviations is called what? Some of you people that's had this before. Standard deviations, we're going Verde. Between 2 standard deviations is called what? Starts with an N. O. R. M. Normal. Write that down. 2 standard deviations is normal. between two standard deviations is normal. And highlight that because that is very important. And make sure you highlight the two standard deviation marks. That's 67 and what? 99. So 95%. And this is where we get into the empirical rule. I also need you to write down empirical rule. Somebody find it. Who's got a book in here? Look about 2 or 3 pages into. There it is. There it is right there. What's that? What's page is that?
132.
Page 132. It should say empirical rule. Does it? Okay. Learn that. Now we're gonna go over this a good bit this week and next week. We're gonna go over this as well as we're gonna go over the distribution. But 95% is going to fall within two standard deviations. 67 to what? 99. So look, all in there. Okay? What falls between 99 and 107 and 67 and 57? That's called unusual. Put a U there. That's called unusual. I'll put that in dang old, I don't know how to say it in Spanish. Lemon. How do you say? Huh? One more time. Amarillo. Amarillo. Okay. Lemon. De limon. Okay? Put some French. It's called Franish. Dang old French and Spanish. It's limon. Okay? Yeah. That's called unusual. So you put a U there. Put a U. That means unusual. So if my number is between 99 and 107, that's unusual. And then what's outside of unusual? You dang old 6-foot third grader. You dang old Michael Jordan. Okay? They're out of the norm. Okay? That's your outlier. Okay? Dang old high school basketball player got cut. Okay? So outside of 107 and below 57, put an O. That's outlier. And that's your 3 types of titles that you have for this bell curve. You have normal, you have unusual, and you have outlier. Now unusual and outlier are pretty much similar. Outlier is just a further out representation. Okay? Question, gripe, complaint. Now, the only difference in this, and when n is odd, what's the difference when n is odd? You just take the middle what? You just take the middle number. So write that down. When n is odd, that's the third yawn. I counted. I'm going to throw you out. When n is odd, you just pick the middle number. But you got to put them what? And you got to put them in order first. Okay, so when n is odd, you pick the middle number. The rest of it's the same. Now, I have covered pretty much, I think, 2 sections in 3. I think 3.1 and 3.2, maybe 3.3. Okay? Now, I want you to work on those 3 sections and send me questions because I will look at them and see if I missed anything, but I don't think I have.
So what's the sections go through?
I'm sorry, what?
The sections for this?
3.1 through 3.3, I think.
Empirical starts at 3.2.
I'm sorry, what?
Empirical is on 3.2.
Okay, yeah. I think, I'm going to go over the empirical rule later. What was your other question over here?
Why did you say that you finished your?
Let me see, 3.3, yeah. Wait on me. There's the empirical rule. Yeah, 3.1 and 3.2. Right, 3.1 and 3.2. I just covered 3.1 and 3.2. We'll work on 3.3, which is a frequency distribution when y'all come back, or I'll just go over homework questions when y'all come back, either one. Any questions? All right, I'm going to cut it off, and y'all have a good day. The thing should be coming around. Y'all have a good day. See y'all whenever. Wednesday.